Hi, folks. I'm sorry that I can't make the roundtable today, but I would like to kick off with a very brief presentation for you to set the scene as to the sorts of things that we're going to be talking about today. I've called it Net Zero Carbon, Smart Buildings, Technology, and Retrofit. And this is my view on how I think we're doing, the size of the problem, and perhaps where we might have to go in order to make retrofitting our existing buildings appropriate for the challenge that we've got for the future. A quick intro to myself. I'm Dr. Matthew Marson. I'm Managing Director of the advisory practice here in EMEA for JLL Technologies. And in terms of my background, I've set up the Smart Places practice at WSP and most recently finished at Arcadis, where I was the global market sector leader for technology. And I've also been very lucky in my time to have been featured for some cool awards and have authored some stuff in the Encyclopedia of Sustainable Technologies. But without further ado, and to talk about the issue in hand, I wanted to start by looking at the size of the issue that we've got to deal with, particularly when it comes to operating buildings. I definitely think that it's a game of retrofit. In 2050, the predicted building stock that we'll have in the European Union, 75% of that is already here today. And only 25% of what we'll have, we need to make in the few short years between now and then. I'm sure we've all seen this stat here about the contribution that buildings make globally to CO2 emissions, with 40% coming from buildings. So, if anybody needs to get on and look at how we cut that, it's definitely us as built environment professionals. If we're then to look at the operations of our buildings, and here I've taken some stats for most commercial buildings, today they operate with an EUI or energy usage intensity, which seems to be the metric that's winning in operational kind of carbon performance. Is this most of the commercial properties that we have here in London operate at about 160 kilowatt hours per meter squared per year, whereas the best in class that we can do for design of new buildings is 110, which isn't that much of a reduction, particularly when you consider that if you want to operate your building at net zero carbon, you're looking at a rate of around 55 kilowatt hours per meter squared per year, which means that we've got to reduce our consumption by about 105, which will be no small feat. If we then consider what's the energy spend across a typical commercial building, you would normally use about 40% on your HVAC, the heating, ventilation, and air conditioning. You would spend about 5 on your lighting, and then the rest of it is your plug load. And effectively, what that means to us, if we want to take an existing building and the ways that we currently work and use it, is that in the summers we're likely to be sweltering because we won't be able to put on the air conditioning. We'll have to bring blankets in the winter in order to keep us warm. Don't even think about the lights. It's time to buy some candles because we definitely won't be able to turn those on. And that if we have to use a device of any sort, then we've got to bring it fully charged and it must last us the day, which doesn't really solve the problem. It just moves it elsewhere. There have been some really good bits of research and kind of design guidance done in the past couple of years since all of the climate emergency declarations that governments, companies, and other bodies have done. And one of my favourites so far has to be this one from the LETI, the London Energy Transformation Initiative, which is an amalgamation of all sorts of individuals that care from really good brands who have sat down, got their heads together, and pulled together this design guide that looks at ways that you can look at both embodied and operational carbon. For the purposes of this conversation, particularly when I talk about technology, I'm going to focus it around operational energy, where they say that actually to get to net zero, it's pretty easy. Firstly, meet your UI target, look at some heating demand stuff. Perhaps you then use some new low carbon heat for technologies that either exist or don't. Then you should have some demand response as part of how the building operates. You then might have some on-site renewables to help offset that last bit that you've got going. And finally, some data disclosure, knowing what's going on, the bills, your meters will solve the entire problem. And I'm not so sure. As a techie, I kind of want to dial into this part here around data disclosure and see what that means. And if you to read the guidance that they've got, it's a little bit lackluster. It basically says get some meters and then tell people what your meters say. And I don't think that's good enough. I kind of want to almost write them a new section on technology where one of the first things that I expect people to have is something like HVAC analytics system. Now, it's difficult to show a picture of what does machine learning algorithms run across all of the points of data that you've got on your building management system. But this is an example of one I did in 2016 at a building called The Dock in Dublin, where we were effectively taking the building management system in the basement, which I think is a glorified alarm clock because it's got some times and some temperatures and it goes off if there's a problem, and it adds actual engineering kind of calculations and insight across the entire system, not just at the machine level, in order to work out things that you can do that would save energy across the building, be that correcting things such as simultaneous heating and cooling to mix what is effectively outdoor or outdoor air temperature, where the biggest kind of issues are with set point variance, or even some cultural stuff, which is what this front end graphic, which was about, which was on a large touchscreen panel in the foyer that people could go up and apply different filters to see what their energy consumption means in kilowatt hours, equivalent kilograms of CO2, if that means something to you. The most popular one was obviously cost. And what this drove was a bit of a culture of being green, where we could say, come on, fourth floor, fifth floor's whooping your ass. It's time to get green. And, you know, they turned it into silly games and it definitely took it in the right direction. Where the actual sort of engineering comes into this, that a BMS would never pick up, is here we're looking at the on-off statuses, where off is at the bottom and on is at the top for 4 different boilers. The goal here is to, this was for a retrofit building, to meet the winter set point. But if you were to sit and actually do the engineering calcs on it, then one boiler has perfectly sufficient capacity in order to meet set point. You would obviously not want to stress a boiler that hard, so perhaps you'd have 2. But as part of this sort of experiment, we, as you can see, rewired them so we only kept the top one on and then switched off the others. And from a very simple point of view, that means that we're now not heating up and cooling down 3 other different boilers, which not only comes with sort of parts fatigues issues, but is also a massive waste of energy in terms of it being up and down all the time. And from my sort of back of the napkin maths here, if you've got 4 boilers operating at about 80% with all of their ups and downs, and you're typically spending $40,000 trying to do that a year, if you take that down to 1 boiler and really stressing it at 100%, you're looking at a saving of 110k, which more than covers, in this one example of energy conservation measure, the cost it would take over a number of years to implement this sort of technology. A very simple kind of 1D type of analysis here, but it sort of does the point. So for your conversation today, and maybe after, you more than welcome to use the link here and the QR code to listen to part of a documentary that I did with the BBC, which looks at how smart tech can help to tackle climate change. But for the purposes of your actual conversation today, and perhaps some of the challenges that I have for you, is maybe some starter questions. What technologies can we easily retrofit to reduce our resource consumption? What technologies can we retrofit to drive energy generation that is sensible, practical, doesn't look silly, etc.? Which of these technologies do you think will be the most impactful? And how do we communicate these ideas most effectively to other built environment professionals so that we have more success with it? Have fun and hopefully speak to you soon.